So now let's do 15.2, and we're going to be simplifying radicals. And I'm going to introduce you to two rules. One I actually already gave you. It's the product rule for radicals. So suppose all variables represent positive numbers. Then we have two, the product rule for radicals. Actually, for you guys, it's called the product rule for square roots. But when you're introduced to other types of radicals with different indices other than 2, it's going to be exactly the same. The square root of a times b is equal to the square root of a times the square root of b. And the next one I'm going to give you is called the quotient rule. So the quotient rule, and actually you don't really need, and I just misspelled that, I before E except after C, right? The quotient rule since really division is a certain type of multiplication, is the same. A divided by B is equal to the square root of A divided by the square root of B. Now I want to tell you why we really don't need that. That the product rule is all we really need. The reason being is because you all have to remember that when you divide a number a by b, you already know that b is non-zero. So that's equal to a times 1 over b. So we get, using the square root, now it's a product, that's the square root of a times the square root of 1 over b. And that's exactly what this is here, because that's the square root of a times the square root of 1 over b. But sometimes it's nice just to see it in that rule, in that form. But that's the product rule and that's the quotient rule. So we're going to completely simplify radicals. So that's the next thing we have to do. So I'm going to give you some more terminology. So just to kind of recap here, the sign itself is called the radical. And later on, not for this class, of index blank. And that blank will be a number right in there, like 2 or 3 or 4. But for right now, we're calling that the square root sign, which is the same thing as a radical sign of index 2. But we're not going to ever be writing this index here. But this is called, even when it's the square root, we can call it the square root sign, but it's really called the radical. And here, the number, this here, is called the radicand. I really don't like that. I don't like that name. I'm going to rather use what most people use, the expression or number, as it may be, under. So the entire thing, so the radical is just the symbol, that weird, I don't know what you would call it, that symbol right there. The b is the radicand, or the expression under the radical. The last thing is, what is the entire thing called? Well, both of them together is called a radical expression. So let's talk about, so really this is talking about radical expressions. So we have to pose a question, because you're going to be asked to simplify radical expressions. So when is a radical expression simplified? When is a radical expression simplified? So my answer is going to be an answer completely detailed to when that radical is the square root symbol. And I'm going to write it here. When the square root symbol or when the square root is the radical, then the radical expression is simplified when no perfect squares remain under the radical. So we're going to be using the product rule an awful lot. And what is a perfect square? That's another term. A perfect square, P-E-R-F-E, perfect square, is any integer, specifically natural number, or variable term raised to, what power do you guess? The power 2. So those are going to be what we're using. Just the concept is, well, how do I know when I've simplified it? Well, you know when you simplified it when no perfect squares remain under the radical. Well, what's a perfect square? It's any natural number or integer or variable term raised to the power of 2. Sounds like it's hard, it's not. So let's just do some exercises. Examples always help. Minimize this. Where's my thing? Okay, that will do it. So we're going to simplify the square root of 18. So this is what you do. Somehow you have to discover if 18 is the product of any perfect square. So one way to do that, one way, you may know it already, is to factor 18. 18 is 2 times 9, and 9 is 3 times 3. So 18 is equal to 2 times 3, which is 2 times 3 squared. So this is equal to the square root. And what we want to do here is we want to write our squared terms, or any term that is of an even power, first. And then we use the product rule for radicals. So that's the square root of 3 squared times 2. So the product rule allows me to split them and take the square root of each of those factors. And I already know that the square root of 3 squared is 2 divided by 3 to the 2 divided by 2, and that's times the square root of 2. So 3 to the second power divided by 2 is 3 to the first power, so it's 3 on the square root of 2. So the factorization is going to be helpful. But sometimes you don't want to factor, so it would be really good to know and have memorized the following. And you should already know them. Might actually be better to go higher. But 1 squared is 1. So this is the number, and this is the number squared. 2 squared is 4. 3 squared is 9. 4 squared is 16. 5 squared is 25. 36. 49. 64, 81, 100, 121, 144. Knowing this, I can look at the square root of 18 and realize that 18 is 9 times 2, and the square root of 9 is 3. So I can remove that out from underneath the radical, and the 2 has to stay behind. In other words, if you know a number is a perfect square, 9 is a perfect square, it can escape from out from underneath the radical, but when it escapes, it sheds its power and becomes its square root. So we'll do those many different ways. I think for a lot of these, the easiest way will be square root of 12. You could factor it, but we know that the square root of 12 is the same as the square root of 4 times 3, which is the same as the square root of 4 times the square root of 3. And you already know that the square root of 4 by the table that you just have memorized is 2 times the square root of 3. So 1b, 1c. The square root of 33. Now that's not on our list, so let's factor 33. 33 is clearly divisible by 3 and 11, so 33 is equal to 3 times 11, none of which have an even power, so this cannot be further simplified. Why? Because it doesn't contain, when I break it down to its primes, none of those primes are raised to an even power. Oh, well, 160. Let's do 160. I'm going to bet it's not as bad as you're thinking. So the square root of 160 is the same as the square root of 16 times 10. So I recognize that 16 is a perfect square. So using the product rule, that's the same as the square root of 16 times the square root of 10. So that gives me 4 times the square root of 10. But we still have to ask ourselves a question. can the square root of 10 be further simplified? But 10 is equal to 2 times 5, neither of which is a power raised to an even number. So that's as far as we can go. That is simplified as far as it can be simplified. Now let's do number 1e. It's 5. So 5, the symbol right here means 5 times the square root of 15. But I know that I don't know, why did I say 15? This is the same as 5 times the square root of 16. But we know that the square root of 16 is 4. So the answer is 20. And that's completely simplified. And 1f minus 3 times the square root of 50. Let's come over here and start looking at 50. Well, I know 50 is divided by 2, and 2 times 25 is 50. Oh, wait. 25 is a perfect square. 25 is 5 times 5. So this is equal to minus 3 times, we put our perfect square term first, 25 times 2, which is equal to minus 3. Using the product rule now, times the square root of 25 times the square root of 2. So this is minus 3. The square root of 25 is 5. And the square root of 2 clearly cannot be simplified because 2 is prime. And it's just 2 raised to the first power. So minus 3 times 5 is minus 15 on the square root of 2. Now let's go to quotient rule. So it's not going to be bad. So the quotient rule, maybe this is 2a. We'll be doing the same thing. We're just splitting the problem up. So the first thing I'm going to do is I'm going to use the quotient rule. So the square root of a over b is the square root of a divided by the square root of b. But the square root of 25 is 5, and the square root of 16 is 4. That's not so bad. 2b. Look at the square root of 99 divided by 4. Well, using the quotient rule, the very first thing, that's the square root of 99 divided by the square root of 4. So I can already simplify my denominator because the square root of 4 is going to be 2. But the square root of 99 is the same as 9 times 11. And we know what the square root of 9 is. So that's the same as the square root of 9 times the square root of 11. The square root of 9 is 3. Square root of 11 is prime. There are no powers, even powers in its prime factorization. So it's 3/2 times the square root of 11. This is one way to write it. Another way is to write it 3/2 times the square root of 11. I actually prefer this way. And let's do number C. The square root of 125 times the square root of, divided by, square root of 144. So again, the first thing we use is the quotient rule. Now the square root of 144, I know by my table, is 12. So I've got to do something with 125. And 125, you can do this any way you want. It's 25 times 3. Now you could get to the same thing by dividing it by 5. And 125 divided by 5 is 15, which is 5 times 3. So you get that it's 5 squared times 3, or if you know automatically, it's 25 times 3. So I'm going to write that as the square root of, doesn't matter, let's do it 5 squared times 3 just to be contrary. So that's equal to the square root of 5 squared times the square root of 3 over 12. Finishing it up down here, the square root of 5 squared is 5. The square root of 3 cannot be simplified because 3 is prime. It doesn't share any powers that are even, divided by 12. Okay, simplify each radical. Now we have a new rule because look, these radicals aren't raised to an even power. They're raised to an odd power, but it's going to be really simple. Let's take a look. Let's look at an example before we go to there. Let's consider the square root of 2 to the third power. Well, I can't use my rule that I introduced in the last lecture at the very end because my power is not even. But I do know that 2 cubed is the same as 2 squared times 2. Why? Because this is just using my old multiplication rule for powers. X to the a times x to the b is equal x to the a plus b. So 2 squared times 2 is the same as 2 to the first is equal to 2 cubed. And that's what I actually claim it's equal to. So now I'm just going to use my product rule. The square root of 2 squared is 2 times the square root of 2. So that's going to kind of give us a good example of how we have to proceed. So let's go back to the next problem. Not that one. If you're hearing a noise in the back, it's my washer. I never know what you can hear or not. I turn off the air conditioner because it's right here close to where I'm at. But can you hear the washer on spin? If you're wondering what is that sound, is it a helicopter? If you can hear it, it's just my washer on spin. So let's look at the square root of x to the 5th. So what we're going to do is instead we're going to look at, we're going to take 5 and we're going to subtract 1 from it. So 5 minus 1 is 4 times x. Now I'm going to use the product rule. X to the 4th times the square root of x. And from the previous rule that we learned at the very last of our last lecture, that's just equal to x to the 4 divided by 2 times the square root of x, which is equal to x squared times the square root of x. So not so bad at all, is it? So 4b, the square root of y to the 9th power. What do? We subtract 1 from 9. 9 is odd. So if I subtract 1 from it, I get an even number. And then I multiply it by y. So then I use the product rule. And that's equal to y to the 8 divided by 2, because 8 is even, times the square root of y. So that gives me y to the 4th times the square root of y. And for C, it's really simple now. I'm hoping you're seeing that these are really easy, and indeed they are. Square root of a to the 13th is equal to the square root of a. 13 minus 1 is 12 times a. So that's equal to the square root of a to the 12th times the square root of a. And that's equal to a to the 12 divided by 2 times the square root of a, which is equal to a to the 6 times the square root of a. I think we have some more on the next page. Yeah, okay. So we're mixing them all up now. So let's do the first one. Square root of 18 over x squared. For D, square root of 18 over x squared. Well, I'm going to use the quotient rule. Well, in my very next step, I can simplify the denominator. That's x to the 2 divided by 2. And the square root of 18 is, well, 18 is 9 times 2. So that's the square root of 9 times the square root of 2 on the denominator. And x to the 2 divided by 2 is just x. And it's absolutely fine if you go from this step right here to just writing x right here. Absolutely. As a matter of fact, I'm hoping that you will see shortcuts. What I'm doing is I'm using a rule again and again and again until it becomes simplified. Literally, I could write the next step is x to the 1, and then in the next step say, well, x to the 1 is just equal to x. So many times we can skip those rules. The square root of 9 is 3. 2 cannot be simplified to a power. So the square root of 2 is, that's it, we can't do anything, divided by x, and that's my final answer. That's as far as it can be simplified. 4e, the square root of 36 y cubed. So the first thing we want to do is use the product rule. And now I literally have it into an area where I can deal with it. The square root of 36 is 6 because I have memorized that 6 times 6 is 36. I'm going to write y cubed is y squared times y. Well, that's 6 times the square root of y squared times the square root of y. And you should be able to go 6, the square root of y squared is y. And your last term can no longer be simplified. So that factor of the square root of y can't do anything with it. And let's do f. The square root of 80 times y squared. Ah, that's kind of nice, right? Because I'm already given an even power. Really, the work is just finding the square root of 80 times the square root of y to the 12th. Well, let's go over here and do our factor tree for 80. Well, 80 is equal to 2 times 40 is 2 times 20, 2 times 10, 2 times 5. So 80 is 1, 2, 3, 2 to the 4th times 5. So that's equal to the square root of 2 to the 4th times 5 times the square root of y squared. So that's the same thing as the square root. You can take steps here. I'm just going to apply the product rule right now. And I already know, that's supposed to be 12 there, that I can simplify any of these factors that have even powers. And that's what I'm going to do right now. That's 2 raised to the 4 divided by 2 times the square root of 5 times y times 12 divided by 2. So that's 2 squared. And we usually place radical terms or radical factors at the end. So that's going to be y to the 12 divided by 2 is the 6. The square root of 5 cannot be simplified. There's just one more simplification. I can simplify. I know what 2 squared is. 2 times 2 is 4. So the whole kit and caboodle is 4 times y to the 6 times the square root of 5. And we like to have our terms, our non-radical terms first, and then our radical terms second. So this is one factor of non-radical terms times factor of our single radical term. And we'll only just have one single radical term. So which one was this? Oh, okay. So let's do these at the bottom. I think that's all we're going to do is these last 3. And none of these are really difficult if you get it. I mean, it looks really hard. You kind of avoid it, but they're not bad. So this is G. So here, I hope you can anticipate really the only difficulty in this problem is going to, because the exponent on the bottom term is even, is going to find the factorization of 98. And I don't know it myself. We'll just have to figure it out. So let's go over here and see what 98 is. 98 divided by 2 is going to be equal to 39, right? 49. Yeah. We want it to be 49. Because 49 is equal to 7 times 7. So that's equal to 7 squared times 2. So that's the square root of 7 squared times 2. I'm ready to simplify this bottom one right now. That's p to the 6 divided by 2. Well, if you need to, we will go ahead and write out using the product rule on the top, square root of 7 squared times the square root of 2. It's not a bad idea while you're doing this. And p to the 6 divided by 2 is p cubed. One last simplification is possible. The square root of 7 squared is 7. Square root of 2 cannot be simplified. It's prime. And even if it weren't prime, its prime factorization does not have any perfect squares in it. P to the 3rd. And that's our answer for that one. You all should try to do H and I on your own. Hopefully, I mean literally, if I were a serious student, I wasn't always as serious a student as I should have been. I certainly became a serious student when I went back to school in mathematics much later in life. And when I was a grad student in my first degree in philosophy, I was also very serious. Wasn't always as serious as I should have been in an undergrad. But as a serious student, if I were looking at this, say, okay, here I have a lecture, I'm going to pause, I'm going to see if I can do this. If I can do it, okay, I've got it. Let's go to that fast forward. I go to one that, I'm not sure if I know how to do that one. Try to do it. See its worked out solution. Oh yeah, I got that one right too. And you can really, the good thing about, the bad thing is I don't see you in person. The good thing is you can tailor the learning experience to your own needs. For those of you who are more advanced, you don't have to be bored. You can fast forward through. So for this one, we need to find the factorization of 300. So clearly, the most obvious thing is to say it's 3 times 100, and 100 is 10 times 10. So 300 is 10 squared times 3. So that's the square root of 10 squared times 3. Notice I already just used the fact that this is an even exponent and I simplified it here. I will simplify it more in the next step. I'm just using the product rule on the numerator there. 20 divided by 2 is 10. So now I'm ready. The square root of 10 squared is 10. The square root of 3 cannot be simplified. 3 is prime. X to the 10th. I hope if you paused it and worked it out on your own, that's what you got. Now let's do the last one of this video. The square root of 16x over z to the 10th. Well, that's equal to the square root of 16 times x over the square root of z to the 10th. I'm going to use the product rule on the numerator. So even though 1 is odd, it's not going to do me any good to write x to the 0 times x to the 1, because that just gives me the square root of x to the 0 is 1 times the square root of x. So that's going to be unsimplifiable. This is going to be z to the 10 divided by 2. Well, the square root of 16 is 4 because we have those memorized. That's the square root of x, and 10 divided by 2 is 5. Is that all of them? Yep, that's all of them. Okay, that's it for this particular lecture.